Dear students, this class I am starting with properties of lubricating well and SI rating. This is basically the fourth ICGT lecture. So you listen it carefully, whatever I am telling, and try to understand from the PPT. Properties of lubricating foil. The well used in engine must serve as a lubricant, a coolant and an agent for removing impurities. That means it is not only a lubricant to remove friction, it also works as a coolant, it cools the engine, and an agent for removing impurities. So whatever impurities, dirt particles, etc., there are filtered by it. It washes away the impurities from the system. That means if the dust particles are connected to the system, dust particles are no more in the system. It must be able to withstand high temperatures without breaking down. The well must operate over a good range of temperature. Means if the well breaks down at high temperature, it loses its lubricating property. And when it loses its lubricating property, as a result of loss of lubricating property, it decreases the lubrication capacity and friction increases. So that's why it is very important that it is able to withstand high temperatures without breaking down. It doesn't break, doesn't react at the high temperature, and the film thickness of the well remains same. It must operate over a good range of temperature. The range of temperature should be known. That is the range of temperature between which the engine will work, the operating temperature range. You know for a particular engine what is the minimum temperature, what is the maximum temperature for operating range. That is found out by testing, by driving the engine at lowest speed and the driving the engine to the highest speed in the test lab. They must not oxidize on the chamber walls. This is very important. If they oxidize on the chamber walls, as a result of that, the rust is formed on the chamber walls. As the rust is formed, the piston rings, the movement is affected heavily by the friction. As a result of friction, the horsepower, a lot of horsepower is used in running the piston through the cylinder. That will affect the ultimate output of the engine. The well should have high film strength to prevent metal to metal contact even under extreme loads. Film strength should be high, that is the boundary film it has. It should be able to contain the film. Actually, the film of the well separates the metal to metal contact in the well. Film is a layer of lubricant well, remains between the piston cylinder and the piston. So what it does, it separates the piston from the cylinder by a thin layer of oil. That well must cling to the surface. It should have the high film strength, that the film remains same throughout a large period of temperature. So what we learned from here, the engine works as a lubricant. It cools down also, and it also helps in removing impurities. It is able to withstand high temperatures without breaking down. That means the well strength should not decrease under any condition at high temperature. The well must operate over a good range of temperature. The well should operate a good range of temperature, that is the operating range temperature of the engine. That's very important. They must not oxidize on the chamber walls. The well must not oxidize on the chamber walls because oxidation provides with rusting. Rusting provides with friction. Friction provides with power loss. So this is very important aspect. Then we come to the next part, the viscosity. The lubricating well should have the correct viscosity so that it flows easily to all the moving parts. Viscosity, if viscosity increases, the well becomes thick. And the well becomes thick, it doesn't flow easily. So, care is taken, a correct viscosity is maintained so that the well doesn't become thicker. And if the well becomes thick, more work is required to pump it because a thick well is heavier. And work required to pump the well to the lubricating system is more. Now that pump takes power from where? It takes power from the ultimate output of the engine. So more the pump uses the work done by itself, the output of the engine decreases. The more the output of the engine decreases, the less is the efficiency of the engine. So too high viscosity is generally avoided. But in case of low temperature region, where the temperature is very low, like Canada, where temperature is minus 20 degrees centigrade, oil viscosity will be some higher proportion. You cannot help it. But in case of temperature conditions in Delhi, where the temperature is generally high, the oil viscosity never becomes too high. It's good for the engine. Viscosity becoming high results in greater friction work, reduced brake work, and hence reduced power output. That's why I said, see, ultimately you are getting some amount of power, say 50 bhp from the engine. Now, generally the well pump takes 5 bhp, 5 hp out of that. So 45 bhp you give as the output. Now, if the viscosity is high, the well pump takes 10 bhp, 10 hp. So the 10 hp, 50 minus 10 hp is 40 hp you are getting as a bhp. So the higher the power required to pump the lubricating oil, the lesser is the power output and less is the efficiency of the engine. Viscosity is highly dependent on temperature, increasing with decreasing temperature. Viscosity increases with decreasing temperature. I have just said, as the temperature of a particular condition decreases, the viscosity increases. And if the viscosity increases as a result of increased viscosity, the power output required becomes less. That means the power output we are getting from the engine becomes less. The fuel consumption may increase by as much as 15%. Fuel consumption, remember, we are talking of fuel. One thing is oil, which is lubricating oil. Another is fuel, which is gasoline or diesel. When the power becomes more, power absorbed by the pump, lubricating pump is more because of the high viscous fluid, the fuel consumption also increases to run the pump. And as much as 15% fuel consumption is there. That means your average of the car decreases. Specific gravity, this property is of little importance except as an indicator of weight and volume, and so we won't talk much about that. Now comes an important point, that is pour point. Pour point indicates the temperature below which the lubricating oil loses its fluidity and will not flow or circulate in the system. That means below that point, the lubricating oil is highly viscous. The moment it becomes highly viscous, the flow decreases. It will not properly circulate in the system. That is very, very important for an engine. The moment the lubricating oil starts working, the temperature of the piston increases tremendously. Piston cylinder arrangement, I mean to say, increases tremendously. This high temperature of piston cylinder arrangement affects the engine performance. In the sense, when oil loses its fluidity, the more friction is there, a lot of power goes into running the piston within the cylinder. The more power goes in running the piston within the cylinder, this works against the system. A lot of power is consumed, say, in running the piston within the cylinder, then what power you will be getting at the wheels? The wheel which is rotating, which the engine is giving as an output to the car. The characteristic of the oil is important in low temperature. Pour point, low temperature means pour point must be at least 150 degree Fahrenheit lower than the operating temperature to ensure maximum circulation. Means you have a particular operating temperature at which the car is working. Now you have two ranges of temperature. One is maximum operating temperature, one is minimum operating temperature. Now below minimum operating temperature, it should be further 150 degree Fahrenheit lower than the minimum operating temperature to the pour point should be, understanding no? Pour point, which is the point at which the oil loses its fluidity and it ceases to act as a fluid. The lubrication capacity decreases tremendously. So the pour point must be as low as possible because the fluid must always remain viscous. Otherwise, there is no purpose of using it. Pour point must be at a temperature 150 degree Fahrenheit lower than the operating temperature. Means what is the minimum operating temperature? उसी से another 150 degree Fahrenheit it should be less to ensure maximum circulation. To make the circulation maximum, it should be working at a temperature 150 degree Fahrenheit lower than the operating temperature. That means the pour point plays a very important role in case of cold countries. In cold countries like Canada and certain other parts of the world where the temperature is very low, there is already a high chance of fluid trying to become more viscous or reach the pour point. So it is very important in case of lower temperature countries. The pour point must be 150 degree Fahrenheit lower than the operating temperature at that country. Operating temperature at that country means the pour point of the same engine in Canada should be less than the pour point of the same engine in India. Because in Canada, the temperature goes to minus 20 degrees centigrade. In India, in Delhi, the temperature goes hardly to 2 degrees centigrade or 1 degree centigrade. So the pour point definition is different for Canada and different for Delhi. It is to be worked accordingly. Then stability. Oxidation stability of an oil is its resistance of oxidation. I am talking about the oxidation stability of an oil, its resistance to its oxidation. That means the oil has a tendency to get oxidized. So oil should be having sufficient resistance to oxidation. Due to oxidation, oil forms deposits in the piston rings. What are these deposits? Actually, a rust-like formation. Whenever there is oxidation, there is formation of rust. And rust gets collected in the piston rings and thereby loses its lubricating property. To decrease the oxidation character, certain inhibitors are used. These are chemicals which are used in the lubricating oil to decrease this oxidation tendency so that the oxidation becomes less in case of an oil. Oil should not oxidize. Oxidation is a very bad property of a lubricating oil, oxidation tendency, because again that forms the rust particles in the cylinder, and these rust particles has a tendency to affect the lubrication capacity and increases the friction. So as a result of that, inhibitors are used. Acidity and neutralization number. The lubricating oil should have low acidity. See, the oil goes within the engine cylinder. The engine cylinder is what? It should have a low acidity, because high acidity in case of engine cylinder affects the engine very badly. What acidity does? It eats away the inner parts of the cylinder. It eats away the metal parts. So the cylinder surface doesn't remain plain. If it doesn't remain plain, it makes small holes and ruptures are formed within the engine. The engine becomes old at an early age. Say it's tenure capacity is 10 years, it becomes old at a tenure of 5 years. So that is why acidity is taken care of. The neutralization number is a measure of acidic or alkaline contents of oil. Every lubrication oil has a neutralization number. Now the standard neutralization number is fixed by the car manufacturer. This neutralization, if it goes below that neutralization number, the acidity characteristic is more. So that is to be used accordingly. You have to check the neutralization number of the lubricating oil and then according to you. That is why for every engine, the engine manufacturers generally recommend particular lubricating oil. They check all these parameters and then they tell you that you have to use this lubricating oil for this engine, which is best for the engine. Then comes oiliness. Oiliness is responsible for the boundary layer of molecules that can adhere or cling to a metal surface and provide lubrication after most of the oil gets displaced or squeezed out. Oiliness is an important character. Oiliness means fluidity. The more the fluidity of the oil, the better is performance of the piston within the cylinder. High fluidity of the oil reduces the friction, and as a result the piston moves easily within the cylinder. So lubrication takes a very important part, and oiliness is responsible for in maintaining the proper lubrication. Oiliness is a very important character within the lubricating oil, which is to be maintained by all means. Oiliness should not be affected. Oiliness gives the fluidity character of the engine. Less the oiliness, high viscosity of the fluid. And I am telling again and again, viscosity of the fluid is dangerous for a lubricating oil. It should not be highly viscous. Highly viscous means high power requirement. Highly viscous means less fluidity, so less circulation. Lots of problems. So, viscosity of the oil should be always at lesser point. But it should not be too less. Too less viscosity is also bad. Too less viscosity of the oil drops the oil characteristic. That case, heat produced is more. So, too less viscosity is also less. So, a balance is to be maintained between the minimum viscosity and maximum viscosity. But it's always better to have a lesser viscosity than the higher one. Now, SI rating. This is the standard rating of lubricating oil used in a viscosity scale. Commonly used viscosity grades are given here. You can see SI5, SI10, SI20, SI30, SI40, SI50. The oil with lower viscosity grades is less viscous and is used in cold weather operation. That means the oil having SI5 is the least viscous and the oil saying SI50 is the highest viscous. You can see from it is starting from SI5 and going up to SI50. SI5 is the less viscous, SI10 is higher viscous, S20 is still higher, 30 is still higher, 40 is still higher, and 50 is SI50 is highest viscous. So what is done in case of cold countries, cold weather conditions, when the oil is to be used, the lesser SI fuel is used. For example, SI5 is better as compared to SI50. You cannot think of using SI50 in a condition where the temperature is minus 20 degrees centigrade, minus 30 degrees centigrade, minus 10 degrees centigrade, like that. But you can use SI5. But yes, in case of Delhi in summer condition, you can use even SI50. This is a high viscous fuel, but no problem. In case of Delhi, maybe the high viscous fuel will do because the temperature is very high. That's 45 degrees centigrade. So you have to take care in case of cold weather. There is a tendency of using the lubricating oil getting viscous. So you should use in cold weather a less viscous, lesser grade SAE lubricating oil. In case of summer weather, the lubricating well, in case of summer weather, the lubricating well can be little high viscous. Is not much of a problem. That is why the well with lower viscosity grades is less viscous and used in cold weather operation, and modern high temperature, high speed, close tolerance engines use high viscosity grades well. Modern high temperature, high speed, close tolerance engines use high viscosity grades well. That means in modern case, what happens? In this case, the engine is running generally at higher speed. Engine running at higher speed means the temperature of the engine is high. So you need to decrease the temperature of piston cylinder arrangement friction. To do that, you have to use the lubricating well of higher viscosity, because higher viscosity has a higher film strength and it decreases the friction. So it's very important to use a higher viscosity fuel in case of modern type of engines, because modern type of engine are high operating temperature engines because of high speed, high pickup and all these facilities. When certain polymers are added to well, the temperature dependency of oil viscosity is reduced. When certain polymers we are adding, polymers means certain chemicals, when we are using to well, the temperature dependency of oil viscosity is reduced. That means it becomes proof to temperature, foolproof to temperature. The outside temperature doesn't affect much. These oils have low viscosity grades when they are cold and higher as they become hot. As for example, SAE 10W30. See, SAE 10W30, which is shown here. SAE 10W30. This is SAE 10W30. Shown here. That means the well has a grade 10 when it is cold. W stands for winter. That means during cold weather or winter season, it is having a grade 10. And 30 when it's hot. That means it's hot weather. It is a high viscosity fuel. Try to understand. SAE 10W30 means 10 is the winter condition viscosity, the low viscosity. SAE 10 means low viscosity. But that is during winter. 10W means 10 in winter. But SAE 30 means it is high in case of high, that is used in case of summer. And 30 when it is hot. Commonly used oils in this category are SAE 5W20 SAE, 10W40 SAE, 5W30 SAE. You can see all these. These are indicating the winter and summer conditions it's working. The same oil, SAE 5W20 SAE, means it works at a SAE grade of 5, that is a low viscosity during winter. 5W means 5 winter. And 20-20 means that is working in summer in case of 20, that is high viscosity. In summer, high viscosity doesn't matter. But in winter, high viscosity does matter. That means the same oil can have two different grades depending on the temperature. The same oil you can use in two different grades in different times depending on the temperature. So I think it is clear to you what I mean to say. This is the way an engine should work or operate. Seeing the engine operating properly gives a pleasure to the automobile engineer to a large extent. It's very important the engine works properly and it becomes essential to maintain the viscosity of the oil. Viscosity plays a very, very important role in case of oil. So this is my fourth lecture. This is the end of my fourth lecture. Thank you for attending the class. Give your attendance exactly in the Microsoft team. That's very important. Thank you, students.